Hi there, this is Penelope. This is a short video on powers, particularly where we're multiplying and dividing expressions with powers. This is a short video in the series of short videos on basic arithmetic skills. So when we're multiplying index expressions with the same base, then the indices, that the powers, are added. Let's have a look at, say, x to the 4 times x to the 2. Now, if we didn't know the rule, we could write it out as 1, 2, 3, 4. So that's x to the 4 times x squared. And if we counted them all up, we would see that there were x to the 6. There were 6 of them. But what we can also see is that that's equal to x to the 4 plus 2, which is x to the 6. So we can add the powers. Now, that's a basic one. Let's have a look at this one. 2x cubed times negative 5x to the 6. Whether or not you have the bracket, it'll be the same way. So we multiply the numbers first. 2 times negative 5 times, now there are cubed x's, 1, 2, 3. And then there are 6 x's, 1, 2, 3, 4, 5, 6. Okay, like that. Now let's simplify that. That's 2 times negative 5, that's negative 10. Count up the x's and there will be 9 of them. So normal bit for the numbers and multiplying the x's. We could have done this by 2 times negative 5 times x to the power of 3 plus 6. Like that. 4x squared times 3y to the 7. Now this one's slightly different in that the bases are no longer the same. We have x's and we have y's. So let's do the numbers first. 4 times 3 times x times 1, 2, 3, 4, 5, 6, 7. Now, we can't do anything else except multiply the 4 times 3, which is 12. X times x is x squared, and y, all those y's, is y to the power of 7, because we can't simplify any more because the bases are different. The rule for dividing in expressions with the same base, the indices are subtracted. Let's have a look at this one. Let's simplify p to the power of 6 over p squared. Okay, write it out in full. 1, 2, 3, 4, 5, 6. And p times p. Now, we can repeatedly divide by p, top and bottom, so that we get rid of it. Or we could think of it as really it's p over p times p over p times, now we've dealt with both of those, then it would be p times p times p times p. And if we simplified that, p over p is 1, so that's 1, and we're left with p to the power of 4, which we could have got if we knew the rule by saying that's p to the power of 6 minus 2, which is p to the power of 4. Another example like 24 x to the power of 5 over 6. We can split that up as 24 over 6, oops, lost an x, times x to the 5 over x. So 24 over 6 is 4 times, now put the x's out, 1, 2, 3, 4, 5 over x, and we could do the same thing, so it's 4 times x over x times 1, 2, 3, 4. I'll just write that as that because I've run out of room. So that is 4x to the power of 4. Slightly trickier one would be where we've got 12x cubed over 16x to the 4. Okay, 12 over 16 we can rewrite as 3 over 4 times x times x times x over x times x times x times x. And we could rewrite that as 3 over 4 times x over x times x over x. So let me just count one of those, and one more. Times 1 over x, so they're all 1, and we're left with 3 times 1 over 4 times x, which is 3 over 4x. Sometimes we need to take powers of powers. For example, we need to take x cubed squared, which would be x cubed times x cubed. Now we already know that that's going to be x to the power of 3 plus 3, which is x to the power of 6, or it's actually x to the power of 3 times 2. Have a look at another example, 2x to the 4 cubed. So if we write it out in full, you're not going to make a mistake. So it's going to be 2x to the 4 times 2x to the 4 times 2x to the 4. Collect up all your 2's, that would make 8. Then we've got 1, 2, 3 lots of 4. So it would be 8x to the power of 12. Now, more complicated again, 5x cubed squared times 2x cubed. Write it out in full. 5x cubed times 5x cubed times 2x times 2x times 2x. Okay, collect up your numbers. 5 times 5 times 2 times 2 times 2, so that's 25 times 8 times x. Now 3 times 2 is 6 times x times is 1, 2, 3 of them. So that's 25 times 8. I suppose it could be, no, that is 200, times x to the power of 9. Now we need a meaning for x to the power of 0. I'll tell you, x to the power of 0 is 1. Anything to the power of 0 is 1. You could just learn it. Right, so learn that anything to the power of 0 is 1. But we can kind of prove it, and then it makes sense that it's true. Let's look at x to the power of 4 over x to the power of 4. Now, we know how to do this. It's division, so we subtract the powers, and now we have x to the power of 0. But if we do it the other way, if we do it in a long way, then we've got x times x times x times x over x times x times x times x, which is x over x times x over x times x over x times x over x. They're all 1. So it's 1 times 1 times 1 times 1, which is 1. So that's kind of proving the point that x to the power of 0 is 1. Best you just learn it that anything to the power of 0 is 1. The last slide is a summary slide of what we've just said.